Now, the next topic I want to talk about is bit operations. So, the bit logical operator they were introduced. The theoretical foundation was introduced by British mathematician George Boole. So this is why the true false data type is called a bool in C++. It's called a boolean in Java. So it's come from this guy's name. So he introduced an algebraic system, essentially operations on true false value. This is known as a Boolean algebra, and this becomes this calculus become important in designing the digital computers. So we've seen logical and or before. So those are double ampersand for logical and. So those are operate on logical value, on true false values. So true and true gives true, and so on and so forth. Here, by single ampersand, this is a bit by bit operator. So this means that the two numbers that it operates on are interpreted as bit patterns, and then we're going to apply AND on every bit. So matching the bits, the highest bit with the highest bit, and so on. So for every bit, AND require both bits to be 1 in order to get a 1, and OR require both bits to be 0 in order to get a 0. So so long as there is 1, you get 1. Another very useful operator is the XOR. So this has the property that if it's the same value, the XOR, you get 0. If the different value, you XOR, you get 1. So 1 XOR 1 gets 0, 0 XOR 0 gets 0, but 1 XOR 0 and 0 XOR 1 both give 1. So these are the three bit by bit operators. And another very useful operator is shift operators. So this is I guess the same as the input output for streams, but this is overloaded here. When both of these are numbers, this double less than symbol is represent the shift operator. So the meaning is we want to shift the bit representation of A left k bits. So then the k leftmost bits of A, so the most significant k bit of A is thrown away, and then from the right side we add 0 bits. So k0 bits are added to the end. So for example, if we have a 1 left shift k, that gives the value 2 to the k. And this is the case when k is not that too large. So if we have n bit, then when k is at most n minus 1, then this is true. When k is bigger, then we get 0. So if you shift too much, then you only get 0. So for example, 1 less than 2 will give us 2 to the 2, which is 4. Because we have a 1, we shift left by 2 bits, so it becomes 1 0 0, which is 4. So there's also a right shift. So when we do right shift, then the most significant bit is repeated. So if we are shifting a negative number, so if the highest bit is 1, then we'll be adding ones adding ones to the left. So we're not changing the signs if we are shifting to the right. So one warning is if you are using bit operators, always use parentheses. So do not assume which one should go together and which one doesn't, because it's fairly tricky. In fact, I haven't got it remembered myself, and in fact, sometimes I have a bug in my code due to this. And this is a little bit difficult to debug, because the reason you have the bug is you didn't expect this the precedence wrong, so you are sort of not thinking that it could be wrong. So it will take some time for you to print the state to figure out that's what went wrong. So it's much better just to use parentheses on all the operators that are involving bit operators. So then it's clear what happens first and what happens later.